All right, this is Mr. Smith here. This is Algebra 2, Chapter 13.3, and we're working on evaluating trig functions of any angle. So we've before been able to evaluate trig functions of angles smaller than 90 degrees. We're now going to work on evaluating angles of any measure. Okay, and so this is part 2. So we saw this first part yesterday. So we talked about defining our trig functions a little bit more generically. So instead of opposite over hypotenuse, we say, well, it's the y piece over the radius piece r. For sine, cosine is x over r, and tangent's y over x. Okay, and we're going to use this general knowledge. We're going to use this general knowledge to evaluate our trig functions. And so here was a point, and so we could use this point. So this is the x, the y, and we could use that to find the r through Pythagorean theorem. And then we could evaluate the trig functions based on, again, these properties. Okay. We also introduced the unit circle. The unit circle is basically the same idea, except we're restricting the radius to a unit of 1. And thus, our sine value comes out to be just y. So the y coordinate, whatever that angle is there, whatever that angle theta is, the sine of theta will be y, and cosine of theta will be x. Okay, and so we use the unit circle as a tool to help us understand and know our basic trig functions and their values. Okay. We also looked at specific angles, theta of 270. Here's theta of 360. And so these were those quadrantal angles. So angles of multiple of 90 degrees. And they had some unique properties that we looked at yesterday. Okay. And so that brings us to this idea of a reference angle. Okay. So a reference angle, the idea is if I have an angle measurement, let's say theta here, and theta is bigger than 90 degrees. Let's say theta is 100 degrees. Well, I don't know anything about theta of 100 degrees, but I do know a lot about theta if it were to happen in the first quadrant. And so the idea of the reference angle is it's to give us an angle from quadrant 1 that behaves almost identically to this angle. Okay? We're trying to find two angles that are almost identical, but I don't want to talk about an angle bigger than 90. I want to talk about angles smaller than 90, and so we use this idea of a reference angle. And so now it depends on what quadrant we're talking about. Okay. So if theta is an angle that gets us into quadrant 2, okay, so theta, this is the angle that's in question. Theta is the angle that's in question. But to understand about theta, we're going to use a reference angle, theta prime. Okay. And so this is the angle that we're going to use to help us understand about this angle, theta. And so to calculate theta prime, we just take 180 minus theta, if we're in degrees. If we're in radians, it's pi minus theta. Okay. If theta is bigger, let's say theta puts us into quadrant 3. So the angle now is in quadrant 3. We're in quadrant 3, and theta has to be bigger than 180, smaller than 270. Okay. Again, I don't want to talk about an angle that's between 180 and 270. I want to talk about an angle between 0 and 90, because that's easier for me to do. So again, we calculate a reference angle. To represent the reference angle, we call it theta prime, and theta prime is theta minus 180. Okay? So again, that's going to give us an angle that's between 0 and 90, and hopefully I know how that angle is going to behave, and then I'll know how theta is going to behave. Okay? The goal, again, is to understand what theta is doing by knowing what theta prime does. Okay? And theta prime is a smaller number. We all like smaller numbers, and so that's the goal. All right, if our angle theta puts us into quadrant 4, the way we're going to calculate the reference angle is by going 360 minus theta. Okay, so it depends on what quadrant we're in, how we calculate the reference angle. And it's important that we calculate it this way. Okay, so we're looking for a reference angle, and the reference angle is going to tell us about the original angle. That's the generic goal here. We want to find a reference angle, and the reference angle will tell us about the original angle. Okay. So the next exercise we're going to do is we're just going to calculate reference angles. Okay. So here we go. And I'm actually going to give an example first. So I want to do, let's say theta is 210 degrees. Okay. Now I don't know anything about 210 degree angle. I don't know the sine of that. I don't know the cosine of that. I don't know anything about it. Okay. So first we want to find our reference angle theta prime. So to do that, we need to know what quadrant is theta in. Okay, what quadrant does this angle put us in? So if we go back to the previous slide, 210 degrees, is that going to be in quadrant 2, 3, or 4? It should be in quadrant number 3, right? Bigger than 180, smaller than 270, so it should be here. So to find our reference angle theta prime, we're going to take theta minus 180. We're going to take theta minus 180. So let me write that. So this is quadrant number 3, so theta minus 180, which is 210 minus 180. So this tells us our reference angle is 30 degrees. So here's the idea. Sine of 210 is going to be almost identically sine of 30. Cosine of 210 is going to be almost identically cosine of 30 degrees. And so what I want everyone to do right now is to pause, and I want you to do that. I want you to put your calculators in degree mode, and I want you to take sine of 210, and I want you to take sine of 30. If you're watching at home, I want you to do the same, because I want you to see that these two are very, very similar. They're not exactly equal. They're not equal, but they're almost equal. And I also want you to do this with cosine of 30 and cosine of 210. Okay, and I want you to find what these equal. So do sine of 210, sine of 30. Do cosine of 30, cosine of 210. Okay. Pause the video now and work through that, please. All right, so what you should see in this exercise is that sine of 30 and sine of 210 are related. The only difference is they're the negative sign. And cosine of 30 and cosine of 210 are related. They're the same numerical values, and that's going to always happen. That's the value of this reference angle thing. The only difference is whether it has a negative sign or a positive sign. And so we need a way to know that, and I'll show you how we do that in a moment. Okay. All right, so that's the goal of this whole reference angle thing, is to get us two angles that behave the same way. Okay, so sine of 30 and sine of 210 behave the same way. All right, so let's go to the examples that they gave us now, and I'm going to erase a little bit just to make some space here. And so we want to find the reference angle for theta equals negative 165. Now the first thing I would recommend doing here is I'm not really good with negative angles, so let's make this just a positive angle. Right? So there's some positive angle that's coterminal with negative 165. And so let's figure out what that is. So negative 165 degrees is the same as what? What is it? 195? Is that right? Okay, right? Because if I think about this the other direction, all right? So let's draw it just here. So negative 165 would be around, something like that. Okay, so this is negative 165. And so if I want to think of this as positive direction, I need to come around like this. And so that should give us, hopefully, 195 and 165 add up to 360. And so this should be the positive direction. Okay. So notice I've not done anything with reference angles. All I've done is made use of coterminal angles. So now I can think of this in a positive. So 195 is in what quadrant? It's in quadrant 3. So to find theta prime, which is our reference angle, I'm going to take theta, 195, minus 180. And so this, in this case, I get 195 minus 180 is 15. 15. So what this says is that 15 degrees behaves the exact same way, almost exact same way, as 195 degrees will. So if I take sine of 15 and sine of 195, I'm going to get the exact same answers except for their signs, positive or negative. Okay. And so this is really useful if you don't have a calculator, because all you have to know is the first quadrant, and now you can calculate any angle. That's the vision of this. All right, let's go ahead and calculate the reference angle for 7 pi over 4. Okay. So we're going to keep this in radians. I know you guys are uncomfortable with radians, but we need to practice with them to build your comfort. So theta equals 7 pi over 4. And here's how I'm looking at that number. If that's at 8 pi over 4, that would be 2 pi, which would be a full circle. So this 7 pi over 4 is probably in what quadrant? Yeah, it's got to be in quadrant 4. I mean, it's all. If it was 1/4 of a pi, it would be a full circle. So since it's 1/4 less, it should be in quadrant 4. So to calculate the reference angle in quadrant 4, we take 2 pi minus theta. Remember, this is the radian approach. So 2 pi minus theta. So theta prime, our reference angle, is going to be 2 pi minus 7 pi over 4. And now I need a common denominator. The common denominator will be 4. So 8 pi over 4 minus 7 pi over 4 equals pi over 4. And this is our reference angle. Again, what this means is that 7 pi over 4 and pi over 4 are going to behave the same way. We're going to get the exact same numeric values. We just need to check on the signs. Okay. And so I don't have to know what sine of 7 pi over 4 is if I know what sine of pi over 4 is. By the way, just to check, pi over 4 is how many degrees? It's 45. Okay, we should start to build that connection. All right, so this is the introduction to reference angles. But now how do we match the signs? How do we match the signs? And so this chart tells us that. Here we go. In quadrant 1, all 6 trig functions are positive. In quadrant 2, only sine and cosecant are positive. All others are negative. In quadrant 3, only tangent and cotangent are positive. All the other ones are negative. In quadrant 4, cosine and secant are positive. The other 4 are negative. Now in pre-calculus, I'm pretty sure you're going to have to memorize this. For my class, I'll give this to you. Okay. But this should make sense when we did that example with 210 degrees and 30 degrees. Right? Remember, I'm just going to go back to that quickly. It's gone. Remember that when we took sine of 30 degrees, we got 1/2. But when we took sine of 210, we got negative 1/2. Well, that's because sine in quadrant 3 will always be negative. Okay, so now depending on where the angle is, I can tell you, for instance, in quadrant 4, the sine function will always return a negative value. The sine function will always return a negative value. In quadrant 2, the sine function will always return a positive value. Okay, so whenever I take sine of some angle that's in quadrant 2, right, so it's between 90 and 180, if I take sine of that, I'll get a positive number. Okay, so let's see this in application. All right, let's see this in application. So the first thing they do to make this problem difficult is they give you a negative angle. So I don't want to think about a negative angle. I want to think about a positive angle. So tangent of negative 240, if I think about this in a positive sense, the angle theta in a positive sense, what angle measurement would that be? It should be 120. So tangent of negative 240 is the same thing as tangent of 120. This is simply the idea of coterminal angles, right? I can think of this as negative 240 or positive 120. It doesn't matter how I think of it. Okay. Now I need to address tangent of 120 is in what quadrant? It's in the second quadrant. Okay, so to find the reference angle, theta prime, if I want to find the reference angle in the second quadrant, we come back to this. In quadrant 2, I take 180 minus theta. So theta prime equals 180 minus theta, where theta now I'm going to use the value of 120. So it's 180 minus 120, and so our theta prime is 60 degrees. What that tells me is if I know about 60 degrees, then I know about 120 degrees. Okay, if I understand how a 60-degree example works, then I understand how the 120-degree example works. Okay. But the problem is, most of us don't know what tangent of 60 is, right? Remember, I want to find tangent of 120, so I'm going to find tangent of 60. Find tangent of 60. Now, some of you may go to your calculator for this, and that's fine, but the calculator is not going to give you the exact answer. So to get the exact answer, we need to remember this guy. This is our 30, 60, 90 triangle. If this length is 1, this length is 2, this length is radical 3. Okay. So using this triangle, what is tangent of 60? So here's our 60-degree angle. Tangent of 60 is opposite over adjacent. Opposite over adjacent. So tangent of 60 is the square root of 3. Tangent of 60 is the square root of 3. So now I know that tangent of 120 is also the square root of 3. But I don't know what sign it is. I don't know if it's positive or negative. So to determine whether tangent should be positive or negative, I'm going to look. Tangent is in quadrant 2, and now I'm going to go to this chart. And I see in quadrant 2, tangent is negative. So that means that tangent of 120 degrees is almost like tangent of 60 degrees, except it should have a negative sign in front. And now we're done. Now we're done. Okay. So let me go back through this process. Walk you through. All right. So tangent of negative 240. I didn't want to use a negative angle because I don't like negative angles. So I picked a positive one that's the same measurement. So negative 240 is the same as 120 exactly. You can see that here. Here's negative 240. If you thought about it the other way, you would get 120. Okay. But I don't know anything about tangent of 120, so I need to find a reference angle that I know something about. So the reference angle for tangent of 120 is 60 degrees. What we're saying there is that 60 degrees and 120 have almost identical values. So now I need to know what tangent of 60 is, because 60 is the reference angle. And so to figure that out, I use my special triangle, my 30, 60, 90 triangle, to find what tangent of 60 was. Tangent of 60 is square root of 3. Square root of 3 over 1, square root of 3. So now I know that the tangent of 120 is the square root of 3. But I don't know what the sign is. So to identify what the sign is, I go to this chart. And this chart tells me in quadrant 2. Why quadrant 2? Because this angle's in quadrant 2, right? Here's the angle. It's in quadrant 2. So tangent of theta is always negative in quadrant 2. So this is square root of 3, but it must be negative. And that is the approach. Okay. All right, so let's try the second example. Okay, and eventually I'm going to need to erase the previous one. Actually, I'm going to go ahead and do that now because I'm going to need the space. So let me do this. I want to keep our special triangle, and as I'm doing this, I would recommend you going back through and looking at your special triangles and working on making sure you know them. All right, so cosecant of 17 pi over 6. Let's all right, give me just a second. So I know that a lot of you would like to change this to degrees. But again, that's not going to help you understand or appreciate radians. So I'm not going to do that. Okay. So don't be a radian hater. It's just another measurement system. Okay. And it's equally as valuable as degrees. It's just you haven't learned it all your life. Be mad at your other teachers who have held this knowledge back from you. Yeah, it's the same idea as Celsius and Fahrenheit. Right? It's two different systems. They both measure the exact same thing. All right, so we want to find cosecant of 17 pi. Actually, let me bring this down a little. Cosecant of 17 pi over 6. Now, first of all, what is cosecant? Cosecant is a trig function that measures the hypotenuse, the ratio of the hypotenuse over the opposite side. Right? Cosecant and sine go back and forth. They're together. It's just they're the reciprocals of each other. Okay. Now, 17 pi over 6 is more than one revolution or more than one rotation around a circle. So the first thing I want to do is I want to get a coterminal angle of 17 pi over 6 that doesn't involve more than one rotation around the circle. This number's too big. It doesn't have to be this big. I can simplify it. So to do that, all I'm going to do is take 17 pi over 6, and I'm going to subtract 2 pi. All right, because 2 pi is one full rotation. 2 pi is one full rotation, so I'm going to subtract it out. And so to subtract here, I need to get a common denominator. The common denominator will be 6. So 17 pi over 6 minus 12 pi over 6, which is 5 pi over 6. Okay. So cosecant of 17 pi over 6 is the same as cosecant of 5 pi over 6. Okay, those are coterminal. They get you to exactly the same place. The only difference is 17 pi over 6 does an extra full spin that we don't need to consider. So now the question is, what quadrant is 5 pi over 6 in? What quadrant is 5 pi over 6 in? And the idea here is that 5 pi over 6 is smaller than 1 full pi. Right? To make it 1 full pi, it would have to be 6 pi over 6. Okay, so that should tell you that 5 pi over 6 is in the second quadrant. Okay. So now I want to find my reference angle. So theta prime is going to equal, in the second quadrant, in quadrant number 2, I'm going to take pi minus theta. Okay. Again, pi gets me here. Minus theta will get me this angle here. Okay. Sorry. So, pi minus theta, and I'm going to use my smaller number, my nicer number, 5 pi over 6. So again, we're just trying to get to the reference angle piece. We're just trying to get to the reference angle piece. So to get a common denominator, I need to have 6 pi over 6 minus 5 pi over 6. And so the reference angle will be pi over 6. Here's what that does for us. I don't know anything about 5 pi over 6 because that's not in quadrant 1, but I may know something about pi over 6 because that's in quadrant 1, right? That's an angle measurement that I should have more familiarity with. Okay. And so at this point, for everyone's sake, I want to convert pi over 6 back to degrees. So pi over 6 is how many degrees? It's 30 degrees. Okay. So now what I'm really trying to find is cosecant of 30 degrees. Okay. That's really what I'm trying to find. Cosecant, and I'm going to write this, I cringe to do it, but I'm going to write it as cosecant of 30 degrees, because 30 degrees and pi over 6 are the same, so let me write that as well. Cosecant of pi over 6. And now I come back to my 30, 60, 90 triangle. I come back to my 30, 60, 90 triangle. That's why I left it. And I want to find cosecant of 30 degrees. Okay. I want to find cosecant of 30 degrees. Okay, so that's our reference angle. And cosecant is what side over what side? Right, so sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. So what is cosecant of 30 degrees? It's 2. So cosecant of 30 degrees, or cosecant of pi over 6 degrees, is just 2, which means that cosecant of 5 pi over 6 radians is also just 2. Right? The reference angle tells us about the original angle. So if I know about this, if I know that, now I can talk about this guy because I know that 30 degrees is a reference angle for 5 pi over 6. However, one last thing though, we need to check for the sine. Okay, so what quadrant are we in? Right, our angle here is in the second quadrant. So we want to see is cosecant positive or negative in the second quadrant. And I see that cosecant is positive. So that means whatever this number is, it should be positive, and it is. So, okay. All right. All right, so this concludes the lesson on section 13.3. Thanks for your attention. Have a great day.